Is it recording? Okay, sorry. Okay, so now we're going on. Now we're going into how we're going to regulate that hormone activity. Make sure that you're doing the correct thing at the correct time. And remember that this is all about maintaining homeostasis, maintaining that same state inside of the body despite changes in the external environment. Okay, there are 3 different ways that hormones can be regulated. The first is that they can monitor nutrient levels themselves. For example, calcium. Blood calcium needs to be maintained at a consistent level because remember that the calcium is used for a lot of different things. It's used for how neurons release their neurotransmitter. It's involved in signaling for muscle contractions. So you need a consistent supply of calcium. And so 2 hormones are put into place to make sure that they keep that consistent level. And so they don't require neural or any other hormone input in order to regulate the level. Okay, so for example, that parathyroid hormone, it's only going to be released when the calcium levels go down. It doesn't require neural or endocrine input. Whereas some hormones, for example, epinephrine. Epinephrine is coming from the medulla, the middle part of the adrenal gland, and it is going to require neural input from the sympathetic nervous system. So the sympathetic nervous system will send those nerve fibers to the medulla of the adrenal gland, and that's going to trigger release of the epinephrine. And what the epinephrine then does is it sort of supports the fight or flight response that's already being kind of taken care of by the sympathetic nervous system. Then we have hormonal control, where lots of the different types of hormones are going to be released when another hormone tells it to. Okay, so in the pituitary, we have in the anterior pituitary, it secretes tropic hormones, and those tropic hormones are going to cause the release of other hormones. Okay, so let's go through the pituitary a little bit more. Here we are looking at the hypothalamus. Again, hypothalamus, if you think of right in the very middle of the brain, underneath that, that's the hypothalamus. And the hypothalamus then is connected to the pituitary by the infundibulum. The pituitary has 2 lobes, and each of those lobes secrete different hormones. So you really kind of need to think of them as sort of different endocrine glands. You have the anterior lobe and then the posterior lobe. The anterior lobe is going to secrete tropic hormones, and so sometimes the anterior pituitary is called the master gland because it secretes hormones that go to other endocrine glands and cause them to secrete their own hormones. Okay, so for example, thyroid stimulating hormone goes to the thyroid, and it causes the thyroid to secrete a different hormone, which is called thyroxine, which helps regulate your basal metabolic rate. Okay, so you have hormones that regulate other hormones. Those are called tropic hormones. Okay, but don't forget, even though the anterior pituitary is the master, the king is the hypothalamus, because the hypothalamus controls the anterior pituitary, and then the anterior pituitary will then control the activity of other endocrine glands. Okay, so let's review negative feedback loops. Remember, the purpose of a negative feedback is to prevent changes. That's the purpose, maintain homeostasis. Okay, so remember that all of this is going to lead back to not changing. Okay, let's go through it real quick. And again, I'm going to talk about some of the specific endocrine glands and hormones. I wouldn't worry about them yet. You want to really focus on the main point of a negative feedback loop. So here is the hypothalamus. The story always starts with the hypothalamus, and the hypothalamus is going to secrete a hormone that will then cause the anterior pituitary to secrete its own tropic hormones. Those tropic hormones are then going to go to other endocrine glands to secrete their own hormones. Now, here's where the important piece of the story comes. Those hormones that are secreted from that second endocrine gland, instead of just they also do their own function in the body, but what they also do is they come back and they negatively inhibit the anterior pituitary and the hypothalamus. Okay, so what they're going to do is they're going to stop the production of this piece here. So for example, the gonadotropin releasing hormone, reduce that levels. That will then reduce the levels of the gonadotropins, which would then reduce the levels of themselves. Okay, so it's a negative feedback loop because it negatively inhibits itself. And the whole point of this is to make sure that these hormone levels, for example, estrogens and androgens in this case, remain fairly consistent. Okay, so the point is to prevent changes. Make sure that you don't have too much or too little. See, so by the way, if you do have too much inhibition and you end up having not enough estrogen, that means you'll also have less inhibition. Less inhibition means an increase in gonadotropin releasing hormone, which increases the gonadotropins, which then increases the estrogens back up. So really it is a very elegant system where you can adjust the levels as needed to make sure that they remain fairly consistent. So what is a tropic hormone? Tropic hormone is a hormone that regulates the activity of another hormone. Okay, so I also wanted to talk about antagonistic loops, and these are an example of a negative feedback loop, but instead of having that sort of circular pathway, you have two different hormones that are opposing each other. So that the action of hormone A causes, sort of opposes or goes against the action of hormone B. Okay, so I'm going to give you a specific example, but I want you to really focus on the point of it, antagonistic loop, not necessarily the specifics yet. So let's talk about calcium levels. Calcium levels is going to be regulated by two different hormones. You have the calcitonin and you have the parathyroid hormone. And what the calcitonin does is it decreases blood calcium levels, and the parathyroid hormone increases blood calcium levels. Okay, so you have two, it's sort of like a tug of war. I like to think of it like a tug of war that nobody wins. Okay, so that when the blood calcium levels become too low, that'll cause secretion of parathyroid hormone, and that's going to increase them back up. And that's going to cause secretion of calcitonin, which is going to increase them back down, which is going to cause a secretion of parathyroid, which is going to increase them back up, and over and over and over again. Okay, so this is a very dynamic relationship. You're constantly switching back and forth. Calcitonin, parathyroid, calcitonin, parathyroid, kind of pushing and pulling against each other consistently in a dynamic, constantly moving loop. And the net result is that the calcium levels remain consistent. Okay, so that's an antagonistic loop. Okay, main point, homeostasis, remaining the same. That's what all of this is about.